start strata, then again E point and F point. So it is improving. So I'll give you some time. Just think, if you want me to go back to that Google image again, I'll go back. So you all just think and decide some point in your mind, like which location is the most suitable location for the foundation. You have to select only one location. Just think like. So you can type in that message box there. I'll see in there. Basically, what I can do, just give me a second, wait. So most of the people are saying going with A and F, B and D, E, D. So one person, Yuvraj, has also mentioned as C. Okay, that is great. So just wait. Okay, it's over. Okay, I'm sorry for the delay, but yeah. So you guys can do one thing. I'll stop sharing this one and I'll go with this. So is the screen visible to you all?
Yes, sir.
So you can just scan this QR code and then just put in. So we'll get a percentage wise. You just have to scan and just put the option, then just select. So A is getting, I think the maximum number of option is 28%. C, very ironically, is the least preferred option. D is the most preferred option. And the chances of D being the most preferred option is increasing. Okay, so I think we have a winner here. So the most preferred option is going with D. And the most unfavorable location is C and B, to be precise. So now I'll just show you guys. So before when we go to constructed site, so what department does before the tendering process? Here as a DPR consultant, he do some study, which is also called as feasibility studies. So on the basis of the tender is done and we quote our prices and then we go on construction. So I'll show you the tender drawing which we got for this bridge. Now. So is the drawing visible
Yes, sir.
to everyone? So you can see what that guy has done. He has put the foundation at all the places possible. You see, he has put at A, he has put at B, he has put at C, then D, E, and F. He has not even left a place. Now, suppose if we are going to construct there and we are going to just excavate this foundation, so whole that slope will be excavating, and then it's just a complete mess. Like this foundation excavating it completely. Now, next thing comes with this problem is that the problem of data which we have. Now, we have site with us. We can do the amount of surveys which we want to do. We can do GOT investigation, drone survey, LiDAR survey, and everything we can do. So now, this is the last activity where I want your input. Is that just again scan the QR code and just fill in. I want some keywords which you can imagine, like if I would be having this data, so then my decision making would have been much better, like deciding like as you guys made D the winner, so making D the winner, the data backing could be more and more stronger, some geological data, something. So you can think as wild as possible, go till the augmented reality, virtual reality, whatever you think like it should be available with the project manager, just think that and just happen, and then we'll see what are new innovative keywords which we are seeing today. Again, just you have to scan that QR code, fill in, then submit. That's it.
Sir, it may also depend on the length of the deck slab, no? Girders, where we have to put piers.
So I was not involved in that project, but that was our company's project. So that span is 500 meter. It's located in Gujarat, Bed Dwarka. Now another longest bridge, 700-meter cable stayed Kapurthala. We are doing it. I'm not actually. I'm only involved in Hilliton projects, but yes, cable. Okay, so answers are started to come. So I think we should see it list wise. Data distance, soil conditions, and so, like I just want to ask a question. Was terrain very much clear to you, seeing that all the data cross profile and those Google images? Was that sufficient? Like sufficient to visualize that problem statement at hand? Oh, we came substrata data, topographical data, geological data, cell size, slope rainfall, substrata data. It's good amount of points we are getting here. That's it. Soil properties, shear strength, hydrological data. It's a very good point, hydrological data. And then, but I can interpret like it's more in focus on soil data, topographical data, hydrological data. Then distance of the valley is also there, shear strength, stealth. They are all come in that soil parameters only. And then erosion is also there. Bearing capacity, obviously, that will come after the geotechnical investigations. Okay, I think that's good enough. I've got a lot of points. I think, but I was expecting someone must be thinking very futuristic. So these are actually already there in IRC. So if you want to put in some more words, you can. So before I'll show something. Okay, so I think it's the safety considerations are there. Okay. Okay, now so I'll show you. When this problem came to my table, that tender drawing was at my table, I was seeing it. I was completely able to see like on the basis of this amount of data, I cannot take a decision, whether it is Google Earth or whatever. I need to go into the site, see something, and actually wanted to visualize so that I can show it to the management, show it to the detail designer, or everyone who's involved in this project. So what we did, now I'll show you. Okay, is the screen visible?
Yes, sir.
Okay, so the first step which I took, exactly what I was saying, a lot of people were saying distance, soil, slope condition, hydrology, erosion. So I wanted everything at one place. Now for doing that, the only solution which I had, which was remaining, was the GIS. The only thing which can do this. So you can see this is the terrain. So what I did, I asked the consultant to make an AutoCAD profile, and I superimpose my AutoCAD profile on this. Now what I can do, I can just go very near to the foundation while sitting in office, while discussing with people. We don't need to go to the site, stand there. These are actual like site coordinates. I can do the measurement here, and I can even open this in my phone. Not even a laptop is required. I can do all those features. The coordinate system, it's UTM, the global coordinate system I have set in. So I can directly visualize in the global coordinate system. If I want to share someone the coordinates, like go to the site, tell the surveyor, if I'm seeing no, this point is not good, I have to shift this foundation a bit below. So I'll just share in this coordinates. You just go to this coordinate, put an offset at site, see what are the features you are having, is it matching or not. And now comes the next situation. So now, as our designer was there, so we decided like the I like why I was like very amazed in that thing. See, no one preferred, but you see, in hilly terrain, placing a foundation at a slope, which a lot of people had preferred with D, actually it comes with its own set of problems. You see, that's a 400-meter valley. Dead load would be very high, and placing a foundation on a sloping that hill is could be quite dangerous. So bearing capacity may be low here. We may increase the foundation side. We may do ground improvement. That consideration, we will not allow any tension to come into the foundation. We will do all those measures, but the best thing is there we are getting a stable ground. Next thing what we did some satellite imagery analysis. We see from last 30-40 years, is there any erosion visible? So this ground has been completely intact. Now we see what we did. So first we made our alignment. Like we wanted to see like how our road is going, how it is interacting. The valley depth which I was telling in the below, it is like touching 160 meters. Then we created an option for location B, because that was the location we were very favorable with. We fixed this location. Then we went to see like what is the scenario which we'll be having. So for seeing this, the substratification, we actually went inside and we saw, and these are actually to the scale drawings. I'm not like it is not scale, it is truly representing what will in reality come at site after the construction. So the foundation was 20 meters by 20 meters. Then we actually, the main concern was the ledge, the hill slope. So you can see I can directly measure. So I have a very good enough 10-meter ledge available, foundation at the most critical location. And you see one more thing, like when you remember that cross section, that tender guy, he has not even considered that there is a certain dip just beside this plain platform. He just put his foundation somewhere in this region. So it was a highly erodible strata. You see the verticality of the slope. We would not be that much like able to in a position to appreciate the slopes, the steepness of this hill in those simple cross section drawings. But you just see here, when I place everything in just one drawing, I'm able to just see a numerous number of opportunities locating my foundation. Now another critical thing which I would like to mention, that guy has also placed a foundation here at point B. If you all would remember, A, B and C, then D was here, then E was here, then F was here. So you see, a foundation is not at all possible at B location, because cutting it would endanger this foundation, and that slope stability is always going to be a concern of putting a foundation here. So we were very sure after seeing this terrain model that if a bridge has to be built, so this span will rest directly here. There will be no intermediate piers which will be put. Now, as you guys had preferred D, so obviously on this side we were also very confident about D, because strata was pretty hard. It was be there. But if I show you the distance from here to here, you see 248 meters. So constructing a single span, as that guy would have pointed out earlier, that the distance is also a very critical point. So type of structure being put there. So cable stayed bridge, as I replied, could be constructed there, but there are very logistic issues with it, transporting that stay cable and all these things there. So a foundation had to come in between. So instead of going there below, so as I would see, like people were also voting for like this position on the top. Instead of going on top, we found this location possible. So because if I measure distance from here till here, so it's somewhat around 160-meter distance. So that can be done with a balance cantilever type of superstructure. No cable shade is required, and there are a lot of bridges which have been constructed with that span. Recently in Himachal, a bridge is inaugurated, Bachal Bridge. It has 180-meter span. So sufficient data was available, and the location of the foundation was very stable. That was the main thing. Now, just coming back to the presentation, now I'll show you that tendon drawing which people had given, but we have made it. Just give me some time, I'll show you that. Go back to the presentation. Okay. So this is a cross profile, and so this was the initial thing which was given to us at the. So as I told you, this is the modified GAD which we prepared to actually go to the site. You see, we located the foundation at the most plain location. Here I was telling you he has put up a foundation, but we eliminated it. If we have to go with a 90-meter span, a foundation cannot come here. It has to go 90 meters here. Then as I told you, though that 248 around 250-meter was not possible to directly go to D, so we needed an intermediate pier, and that also we needed at location C where strata was good, and we wanted to hit as plain as possible and as far as away from this location. Then we came here. So now as a balance cantilever bridge 90, 160, 90-meter was there, so obviously we have to go behind with like high girder bridges. So again there was a question, a very steep curve was present here in the plan, so a straight span we were not preferring. But if we would have given open foundation, that again, that excavation would have endangered that hill slope. So we have changed the type of foundation, went with pile foundation, and then that's how we like decided to traverse this valley. So the main critical point in this, if you would see, if GIS wouldn't have been there, probably would be constructed a foundation here. So because that is what department had considered, that is what on the basis of which tender was given. So that is what GIS does for you. It basically transforms the data which you have. Now that visualization power which it should be with you as a project manager or as a person who is involved in design or execution of the project. One quality is very important which you all should have. It's asking of questions. No matter how silly it may sound, but if you don't ask questions, you will not get solutions. And while asking a question, you should also like focus very much on defining the problem statement in a more detailed way, because if you have detailed your problem perfectly, then you will find a solution somehow. Like we were there, we the main problem for us was that terrain, that soil, those slopes, those erosion, those stability of those slopes, how that will come into play. And we even went on to do the slope stability with this bridge in modeling. So we did everything, and with the help of GIS and that data which we had. So now it is just to show a comparison. So it was here. So he was this foundation we eliminated, and this he was just putting on that vertical slope which I was showing you. So we shifted it backwards, put it in a very pretty stable condition. Then we brought it as close as to river. Then we put the pile foundations here at this location. So that was our solution to this problem. Now I think I can give you some discussion point as we have seen about this GIS thing. So how data evolves. So first I'll be discussing about only that key different sorts of data, which are the sources from where we can get data and how we can utilize. What are its application in highway sector, whether they are tunnels, bridges, highways, and what are some different forms of spatial data. And then the software on which I'm doing all this is QGIS software. And see, this is a very special software. I'll come into come to in very detail. So the journey of human beings in this era of geoinformatics, spatial data analysis, this whole sort of like what we are seeing Google Earth, Google Maps, what ISRO is doing. So it all started that expedition in 1940s, but the first major breakthrough was 1972, when we were able to see a illumined full color image of Earth from a distance. That was obviously thanks to the Apollo 17 mission, which gave us that image. And we were like if you are can appreciate the fact it changed our consciousness, the way we look towards our maps. So they were going to change, surely going to change after this incident, because our imagination, our creativity, it expanded to the horizons. Like we can get the data, cloud cover, we can predict rainfall, meteorology department would be helped with this. In every sector, that breakthrough was going to come after the intervention of the spatial data. So yeah, starting with this breakthrough. And now I'll give you a very silly example. Suppose you have coordinate of two cities, Delhi and Haridwar. It's a very basic example. So you have coordinate of Delhi, you have coordinate of Haridwar. So whatever exists in space, it has a x, it has a y, and it has a z. So you should be sure of that. So when it has a x, y, and z, so it means it has a that is his spatial identity basically of that point. Now the Delhi's coordinate I mentioned and Haridwar's coordinate. So what I have done, I have just put a simple algorithm of distance. I've got the displacement between Delhi and Haridwar is 175 kilometers. Now this is the information which I've got after processing my data. Now what is the knowledge which I can get from this information? The knowledge is very simple. Like basically 175 is not a walkable distance. I'll be needing transportation facilities. And what transportation facilities? Trains, highways. Probably airport is not required, but rather I want very high speed trains so that I could cover this distance in just 2 hours, 3 hours, reduce that time travel. And so this is the place where GIS comes. This is not the this is the work of humans after getting the information, what knowledge we are getting. But this is the place where GIS plays its most critical role. Data we have, algorithm will decide based on our problem. That is why I was saying the most critical thing is defining the problem statement. When we decided our algorithm, then the information which it gives, now from the basis of that information we can take judgments, we can take decisions, we can get knowledge, and we can take very informed decisions in whatever field we are. Now, as you are from IIT Jammu, so I thought of explaining this project also. So earlier in my company, so we were going to work with NHIDCL on this project of NH244. So it's Kherani Chatru stretch of NH244. Basically, we did. I think you all would have traveled. I hope like after that Chenani Nashri tunnel. So whenever we cross Chenani Nashri tunnel from the right hand side, so that Chenani to that Khilani, that road also we had designed. It is completely working right now. Then after that, we designed the extension of this road. So we were like designing a parallel to NH1. Earlier NH1, now it is I think NH44, the way to Srinagar. So in this stage, when we designed NH244, so we had to traverse through Khelani, Doda, Kistawad, Vailu, Donipawa, Asajipura. So I visited that whole area on my foot. To be very precise, I spent months there. And the main thing which I felt the need, so that is the point where I incorporated GIS very much into the highways. Earlier, if you would see the working in the highways, was basically with AutoCAD Civil 3D, Global Mapper, but they are very good softwares. But what they lack is that there's a term called Sangam, that confluence of the data. So GIS can handle a variety of data. It's not just I'm talking about engineering data, but land acquisition maps, land use maps, the agricultural maps, the effect on the society, the locals living there. It can have everything in it, and the decisions you will be in a position to take, it will be much better. So now this is the alignment which I got from my highway team. Now I had to go there and finalize a feasibility report. So now what do I do? So first of all, the conventional method which my senior told me. So I would like also to mention that senior. So that senior is Mr. Alok Pathak sir. So you all must be knowing there is a project going in Red Sea, Tabuk in Middle East. So what they're making a 170-kilometer long city in 3 levels, that too underground. So is a team leader there in a Chinese contractor, basically Chinese Railway Corporation. So I was involved with him in this project. So he told me, Prashant, like you have to go there and first of all take the topo sheets and study them. You draw your alignment over that. And when I got this, so this was the map. I am actually specifically I've shown the signature here, so that I wanted to show the problem I was stuck in when I saw this map for the first time. So this was very tough. But then I understood like I'll have to find a solution, and that solution should be very much easy. So what I straight forward went to my favorite place, GIS. So this is Shuttle Radar Topography Mission. It's based on United States Geological Survey. So it is basically called satellite images. So this 1 arc second, I'll explain to you what is a raster data in the end. I put all the theory part in that. So this raster data, what it does, so it gives you that information about the elevation. So in this image, in every pixel, instead of color is there, we can correlate, but the main information this pixel has is a value, and that value is not binary. It's not in binary terms. It's in the term of an elevation, like as it is going green, so that elevation is going higher and higher. As this color is going more towards dark, so that is more toward coming the river. So the river there was Chenab. So I'm coming towards Chenab. So this is how this image is represented. I just wanted to show. And so this is the platform of your GS Earth Explorer. So I would request you all to go there, register, make ID. No matter you are from bridges, tunnels, or whatever the field, this software is useful for all. And so you have to just go there, put in your coordinates, like you can put in coordinates, this map would appear there, and just click on here SRTM. You have to make your user ID first. That's hardly take 5 minutes to register on this platform. Here you can download this image which I have downloaded. Now this is the alignment which I have transformed it to. So I have contours, I have my alignment, I have my chainage, and these lines are not just some decorations, these are the stream segments. These are the location when rain will come. These hills, I had given some slope factor in while doing that algorithm. So I got the data where I'll be putting my culvert there, where I'll be putting bridges. And actually in this project, one of the major challenges was deciding where to cross Chenab. What is the location we'll be deciding. So these convex features. Then when I showed it to my company, so they all switched. So from that day onwards, I'm very proud to say they all worked on GIS. So those topo sheets is still there. It's still there to do the due diligence with the department to submit them. But now no one works on them. Everyone is on this GIS platform. Everyone wants to visualize this data. Now, see, not just that. I can even get the hydrology catchment area. Earlier, if I will go back to that topo map, if I have to get a catchment area, see, you would see what I would have done. I would have marked my alignment here. Then I would went to the contours and I would have traced with pencil, like how it is going, and then I would have measured them. No, but you see, with this software, it's just so easy. And secondly, the cross checking. Because watershed is the highest elevation boundary from which, if a rain droplet falls, it will come to the bottommost point. So that is the main thing while delineating a watershed boundary. So I can go to each and every location and see whether it has missed some point. But 99.99% of the time, I tell you, it is always very accurate. It doesn't do mistakes until unless your algorithm and the way you have defined the problem is correct. So that is why I'm stressing that much. Like defining problem is the first thing. If you have defined the problem solution, you're going to get. Don't worry about that. But problem should be defined properly. Now let's come to the definition. So I think you all would have now known what is GIS. I don't need to like put a definition in the start only. It would have been very boring. So yeah, so that is in a very simple terms. GIS, it just connects data with geography. So you can see Google Maps here, a person working, satellite collecting data, softwares are working, analysis going on, maps are working, work is going outside. Everything is going in a simultaneously interface, and it's just so coherent and just so synchronized. So this is one of our professor from IIT Roorkee. So the way he defines, so just to know that you should also know that theoretical definition. So GIS is it's basically a computer-based information system designed to accept large volume of spatial data. So now, as Sir has put that spatial data here, but what I feel it's not just spatial data. Obviously, that information we can give it a coordinate and convert it into spatial data, but we can get any amount of data, like whether it's socioeconomic data, engineering data, even the politicians. You must be knowing, like my friends, a lot of friends are working in those agencies who do those poll surveys and all. So they have started using GIS. They are mapping the people who are voting for them in which area. They are making heat maps. So which is the most critical area. So it's being used everywhere. Now coming to the main point. So the sector where we all are involved in our highway sector. So how it is applicable here. So like you can see, like I've already shown you, hydrology study of the bridges, and it's not just hydrology study. It's a very detailed study which you can do. And just to say, like I'm telling where you can your imagination can go, GIS will like go with you till that distance. Like if I can put rain gauge station, I can take data from CWC, put rain gauge stations, and see the intensity day by day, like what is the rainfall intensity. I can do even the analysis of a each segment of the catchment there, like which catchment is more critical. I want to divert that. I want to decrease the impact on my structure. I can do that. Then comes the delineating of stream segment, which helps in drainage analysis. So you have to do drainage design of your highways. Contour maps, I have already told you, it's a very basic thing. It will do if it is doing 3D modeling. That will do. Then, as I was telling you, those the special feature georeferencing of map, those revenue maps, this land acquisition process, it can be make very much streamlined, and which government of India is now doing. Like, if you all must be like well versed with current affairs, what is going in the country in the sector. So Gati Shakti is being implemented. Government is particularly made a very targeted team in GIS field. So they are digitizing each and every layer. They are designing metro layer, pipeline layer, electricity layer. Because I tell you one thing, the day I'll make this road, next day, and it's a well established fact. Next day, pipeline department will come, it will excavate the road and say, I have to put a pipeline. They never come first, they never tell beforehand that we have to put a pipeline there. But when a project is completed, they'll come and they'll start excavating. So they are doing all those things to just make our departments coherent. So railways are working in conjunction with transport ministry. So things are being brought to a similar platform with the help of GIS. And exactly. So ISRO Bhuvan. So the guy, I was very fortunate to meet him. His name is Mr. TP Singh. So he was earlier professor in CPT Allahabad. So that is basically about architectural university, but it has a very big department of GIS. He worked with ISRO also. So he has been made the director of that whole program of Gati Shakti. So that team is called BISAGIN. So if you just have some curiosity, you can go and search what BISAG is doing in the country. They are just doing some great work, and in next 5 to 6 years you will seriously see these things changing. And when you come to the when you will join after college, completing your degrees to the project, you will see NHI, NHIDCL. These organizations are going very much towards the digitization. They are changing the landscape of how infrastructure is being built in our country. The next thing, obviously, drones. So drones, the integration of drone can be done in GIS also. So this is a very basic example. I just didn't want to complicate it. So it's a seismic zone map which I have. I have to find the seismic zone. So I can just put georeference it and just put it on whatever the software I need: Google Earth, Google Map, GIS. The next thing I was telling you about the land use and land cover. So this is the some of you must be from that northern region. So this is the area of Vailu, the Chatru and Vailu. So we were planning a 10-kilometer tunnel here in this location. So we had to do that complete analysis, like which area to bypass, how to get the 10-kilometer tunnels here. And then so this was the whole alignment. So you can see we had the know-how of each and every agricultural data. Where is a settlement built up, people are living, where is barren land, agricultural land, what is water land. So we could very easily modify our alignment so as to skip the effect to the local community. Less and lesser homes are broken, and we can go in a very seamless way towards our endpoint. Now this is another. So this is a bridge over Ganga River. So it is just ended. Now let's see the difference what the drone image analysis can give us. So this is simple that Google Earth. So we have put our alignment. We are doing just trying to figure out how we can measure. But see, if it is a drone here and it is coordinated to its actual projections, we see, like, I can even calculate the length of wing wall. And if I have the topo data, like I showed you what I did in Shimla, lead lidar, I could have even measured the clearance. Is it sufficient? Will I need to raise this LVOP, which is existing location? This is my RHS carriageway. This is my LHS carriageway. How much land I will be going in the left hand side? Whether it is it a right decision to extend it or just demolish it and construct altogether a new structure. So this all can be done in very detail. Now just coming to the technical aspect of this GIS thing. So spatial data, it exists in a lot of forms. There are a lot of forms, but majoritarily there are only two forms in which we deal in a very day-to-day basis, which are vectors and rasters. So now how that bifurcation is done, what is a vector, what is a raster. So vector basically is, you will see the point feature, polyline feature or polygon feature. So this is our vector data, and just wait a second, I'm sorry. So this is our vector data. So like I have to make my road, I have to make my alignment, so that I will import in GIS in a vector form. I'll be using arcs, I'll be using spline, I'll be using polylines, that geometry, polygon features. So these all come into vector data formation. Now, what is raster data? So that image which I had shown you, it is basically a raster form. So as I already told you, the information is like contained in its pixels. So the more and more resolution it has, the more number of pixel it has, the more detailed data we will be having. So now, like coming to the projections. Now, when this data will flow to QGIS, so we have to take a decision of a projection. Now, projection till now, what we studied till BTech level, even when we go to work, like you will see in gate ranks also, I see like that structure and other tunnels in Jammu, other departments are given very much more weightage. So these things which are very crucial to our like day-to-day basis, if you want to go into the management sides in your later career, start you can do with detailed design position. But if you have in your mind like later on you will be setting in some management position, managing a big infrastructure project, taking decisions. So then you need to have a good know-how of each and every sector which is involved in our this infrastructure projects. And this spatial data will ease your jobs like very much. So now major decision whenever a project is there, which projection system to go with. Now we will not have like understood it that much in our earlier studies, but see what this selection can do. Now I see it's just two sort of selection. LHS I have a Mercer 3857. Then I am going with 4326. They transfers Mercer projection, and you see how my distance have changed, how the shape of Earth has changed. Now the problem at hand to any guy who's dealing in this projects like Earth is not flat basically. But when we have to go with maps, when we are going in 3D, it's not that big an issue, but it still has an impact because that 2D map is being extruded to that 3D version, and the 2D maps projection system is what we decided at the initial end. So I'll make it very easy for you. So like suppose I have to draw a figure. So this is the figure. Now in a different projection system, it will go this. Now how I will define my problem. Like suppose if I'm doing the area analysis of countries, like I have to do area analysis of India, Russia, that China, the big countries. So I will probably go with this coordinate system, which is not detailed, which is not very accurate, but on a larger scale, it gives me an effect of a round earth. So I would obviously prefer this. But if I have to see a project in the state of Jammu, Jammu and Kashmir, and some particular area, so I have to look for the very detail. Then I would prefer this coordinate system, where the whole Earth, like if I would say Russia is locating here, it will get distorted. But I'm sure I'm only considered about this grid. So this grid is going to be very much perfect and very much accurate as compared to this. So this only the choice of projection depend on the type of problem I am dealing with. It's basically like circles. It's here. Here you can see the different circles, how the size changes. If you're like tackling a longer area or short area, it depends on just that. Now after you have selected the information, now you have to get the data. So one of the information I had already told you, you can go to USGS and download those SRTM files. But India's platform, it is also growing. That Bhuvan portal, it is there. You can go and go Google, register there also. It is completely free. Some product have some cost, but yeah, your work will be done with those freely available data there. So these are the satellites which are working. So Cartosat. So you must be seeing that the Aryabhat satellite which you first sent. Now a number of satellite ISRO has done, and it is doing a great work. So we have very detailed elevation data with our Bhuvan. So we can take data from there. The pipeline grid, they are doing urban surveys, postals, monument. So this is for some agriculture, that rainfall thing, hailstorm data, rural, urban. You just see the application of GIS, how broad it is. Now, this is something about the GIS software. So what I'll do, I'll directly go to the GIS software, and I'll tell something about tunnels. Just wait. I'll share my screen again. So is it visible?
Yes, sir.
Okay, perfect. Now just see. So this was an location I will show. So okay, so this red line was a DPI line as I was showing you what department is. Now if I'll show you how it performs, see this. Now you tell me how can build a road? How can someone build a road in such an alignment? So a problem came. We told the department that this is going to be very tough. It constantly it here, and it is going down with time. It's not a stable slope. Even the angle of friction, if you will see of a rock, if I even do analysis, majorly we are encountering physics data. So we go to rock lab, whatever GSI value we can calculate, we come the max we can have is 538 degree and see somewhat around 150 kPa. It's not more than that. So in that slope is not going to be stable. And if we have to give a safe and sound alignment, so we have to realign this. So now department as always, so we tried a lot and then finally they agreed. So they gave us four options to like they gave us to analyze and decide like which option we'll be going with, which option we'll be rejecting. So this is the option which they give, which was very closest. So I'll show you. So they in these blue, okay, I'll tell you. In this blue, they are the tunnels, and this black, these are the viaducts. So what that they propose will come with highway, go to tunnel, then again come to viaduct, then again a tunnel, then again we'll go with highway. Now, whenever you locate a tunnel, so there are very important criteria as overburden, the class of rock which will encounter at the site, and one of the most important thing is the portals. How where my portal is located. So if I'll just show you, I'll just declutter it, clutter it. Wait, yes, just see. You see, the portals of tunnel are opening in a depressional zone. So it's a very basic principle. A depression zone always forms there where there is a weak strata in the between and competent rock on the outside. So at this location we cannot at all locate our tunnel portal. So that is why we were able to see because we were doing in this environment and they must be doing with AutoCAD and those contours so that visualization is not that there. It is not that their intent is wrong, they want to give wrong solution. No, it is not like that. It is basically how far we can visualize the problem. So like there is a quote of Rabindranath Tagore, the more we can visualize it, the less easy it is at the site to make it into a reality. So that is it there. So what we did, we changed it. We again changed it. We told if we have to complete this alignment and go, so this is the option. So nowhere it will come into a depressional zone. So here also depressional zones were being encountered. Like if I'll show you. So these are the depression zones. So we located tunnel strategically here so that portal comes at a very competent strata and all. Then next thing which I was sharing is the type of data which I have. So I just told you about vector and raster. Now there are mesh layers, post QGIS layers. Now one very special thing here is WMS layers. So we'll show you that. So this is the Bhuvan layer. I've created it. It's nothing. I just pasted its URL here. And wait, I'll just connect it here. So I connected it. It'll take some time. Hmm. Yes. So now you just see I have 5 lakh layers provided, and these are the layers which are being done by like ISRO. And these are not just like very simple data. The utilization, if you want to have of this data, whatever application it has, it is completely available. Like for example, I'll show you one thing. See. Just give me a second. I'll show you. Now you see, as my project is located in Shimla, so I can get the complete data. So where the alignment is going in the structural origin, where there are dissected hills and valleys, where I'll be having fluvial regions, where our water body is located. So this complete data is there. Not just that, it has land use, land cover data also. So if I tell you about land use, land cover data, which I have already shown for that alignment of G and K. So this is the complete data which we have. So whatever there is built up, urban, rural, whatever it is. So this data we can use and just implement it in finalizing our alignment, finalizing our solutions. Now, if you want to go more deep into geology, it has solution for this also. Like I can see, it can also show geological discontinuities. Like if there is a ridge, if there is a probable fault, joint, axial trace of fault, it can show like anything. You just name it, it will have it there. So that is like one of the major use of this ISRO's portal. What it is doing, it is just completely changing the game in the infrastructure. And it is earlier we were very much dependent on those US satellites and all, but now that ISRO has done really good job. It has a lot of data available. So as I already showed you this QGIS software which I was using, so it has a lot of plugins, GDAL, GRASS, Saga. So it is basically for terrain and hydrology, for processing lidar images. These are all the tools of the vector and raster tools. And this is the base map. Base map you can have anything like whether a drone or something, you can have it. Now the pros of the software, if someone of you is inspired by this lecture and want to really go into this, and actually I would appreciate you all that you should all, like, whatever job you have, just try to visualize it in a spatial environment. So this software, the best thing, it's an open source software. And why I'm very much focusing on this, because this software completely thrives on a community sort of interaction. Like I am using GIS, so I'll develop a plugin for this software, and everyone in this world can use that plugin. So this is the best thing about this software. If you are making something, you cannot charge it. It should be freely available. It's a completely open source community. It has a lots of features, as I told you, plugins. Like if I encountered a problem in profile, a basic plugin I have made in that using that Python coding, so that plugin is available. So like that, people from different fields in different countries, they encounter different problems regarding hydrology, erosion analysis. Like we can even get the potential erosion potential index of a hill, so that this software can do. There is a plugin available for that. Second thing, as I told you, the data is very huge. KML, KMZ, TIFF, CSU, you just name the data. And even if you can't have it directly, you can convert it, then it can bring. So the best thing about this type of data is not an issue for this software. It updates the community is very active. The support system is really good. There are very regular updates on this software, and a lot of material is available on the internet to learn. And now, as I told you, that those 5 lakh layers of ISRO, so we have like sufficient amount of data to visualize, to see the projects in a completely new and different dimensions. And this I would just if someone is downloading, just go for that long-term version. It's the most stable version of the software. Now, cons of the software, it's a bit complex and paid software, and as you can see, like just now it had crashed. So it also crashes sometimes if the data is huge. So those are some cons of the software. But in a short term, if I have to tell you, like I had to do, so I was thinking, shall I put this in slide or not? But yes, so this is the difference between QGIS and ArcGIS. So its UI is very tough of using QGIS. Initially, you will not be able to familiarize that much, but it does the job. It does the job very accurately and very perfectly. ArcGIS may cost you around 20 lakhs a year, the license fees, but UI is very easy. It has a lot of features available. But QGIS is no lower in any aspect. It has all the features available. So yeah, from next day if you all want to start it, so I have these things for you. Like you can go yourself, explore this world of QGIS and do it. So thank you. And if you have any questions, you are free to ask.
So the map you showed earlier for your Himachal project, was the
Yes.
data from Cartosat or was it from USGS Earth Explorer?
No, no, sorry. It was from Cartoset. Cartoset. That data was from Cartoset, and that they had done the analysis of like it also captured aerial images. So in aerial images, we have three bands: red, green, and blue. You must be knowing those colors combination. From those color combination, we create algorithm and then process. So that is the output you would see. I'll go back to that again. Wait. This one. So originally it would have been a very simple map, only three colors in it, but we process it. And actually now Bhuvan is processing itself. So that work is also saved for us. And they are doing it very accurately.
Sir, actually, back in 2019, I did work with QGIS and ArcGIS both. The only
Okay.
thing, the most problematic thing back then was like getting meaningful data, like
See,
extracting meaningful data.
that is the first point in the presentation I told you, na. See, actually that is the whole point of, because I was expecting this, na. If I recommend you, a lot of people will try to go on GIS and they will face this situation, obviously. See, you need to give some time on QGIS, and why I stressed, na, defining problem accurately. Why is it important? Because it will ease your way in finding the solution. As you were saying, na, meaningful data was not available. I feel like if you would have, like with your seniors or some like industry expert, if you would have brainstormed that problem more and more, you have more refined that problem, that statement should be very clear, like what is the issue I'm facing, then data I will have. So see, I'll tell you a very, like very classic example I'll give you. Wait, see, this is what I was doing in consultancy in my previous job, because that demand was not there. As I was in a consultancy, I was not directly engaged with site. In site, it's a different environment. It's like if I tell you 800 people are working on Shimla, including, if I include those permanent laborers. If I include those laborers which come and go, so the figure will go around 1200 people are working on Shimla bypass project, and I'm handling each and every design aspect on this project. So pressure is huge. So I have to deliver very, very, very accurate things there. So that is how I was forced to define problem in a more and more clear way, and that is how this thing came. Yeah, this thing where I showed you that 3D model, where I went to the each and every location. That thing was there from the GIS when day one I started learning that program, but the problem was not there in front of me. And that solution, because if I am having taking the responsibility of coordination, so I have to find it very accurately. I'm very serious in that. If I am seeing a problem, it, the solution should be very accurate. So I did this, the data transformed. Actually, I was also very amazed when I did this for the first time. I also didn't knew QGIS has this capability. So that is why I have told you those two things. To be a bit patient with QGIS, and defining the problem is the most important thing. Like why you are on this software, like what do you want to achieve, what is the problem you are having, and I can guarantee you it can solve any type of problem. Like if I have to mention here, like I think that was a project in Bihar in my earlier company, not this company. So what they had done, so they had put like how my GI journey started. I'm just telling you that story. So they had done some project, and a bridge span they decided somewhat around 50 meter. So DPR was submitted, feasibility was done. It was on the stage of detailed design. A query came that that span is not correct. So then they were all like, how to now reply to this letter and all. So unfortunately, or you should say fortunately, I had written in my CV QGIS because I had done the BTech project. So they all came to me, you have written QGIS, so hydrology होती है उस पे, you do that work. So I was given that, and I did those analysis. I spent my time on that software, and I found out actually 180 meter span is required. But I wanted to be very certain, like if I say that it is a blunder which has been done. As per my analysis, 180 meter span is required. So I went in that river on Google Earth upstream, and there was an NH bridge 1 kilometer upstream, and span was 160 meter, and we were constructed in downstream. So we had to be much more greater than that figure. So finally, we decided 220 meters. We did analysis. So that was the time everyone understood like how this software is important. So then from that point of time, I have never, like whatever problem I have, how like different sector it has, whether geology, whether hydrology, structural problem, locating the foundation, it can solve like a lot of things, and it can save a lot of time and money, and finally it can deliver a very quality product. Yes.
Where you were showing the coordination map of this project, this bridge, was that in BIM or QGIS?
No, actually, I'll go to that map again. Wait. Hmm. See, this is not something BIM or something. It is just QGIS. I have just exported it into a HTML form, and there is also a plugin for that for exporting it. So you just have to export in HTML form on your phone from Play Store. Download an app called HTML Viewer. Keep this file in your phone and open on that. So it will be the same output on your phone also. And obviously these things I modeled. I had drawn this thing in CAD, taken it from this PSIs they designed in Midas and those softwares. So they told me this is the software. I asked them from files. So data I got, and I imported everything on GIS at one platform. Even if you will see this foundation which I was showing, so the geotechnical consultant went there and he told me the level should be 1328. So this is the founding level of actual that foundation which is there. He because above that he's saying this is the minimum level till what you should go. So there is no BIM. And if we'll talk about BIM, India, if I'll say in India, we have a lot of infrastructure sector because the diversity of data is very huge. One consultancy designing on software stack, other is going on Midas, other is going on CAD. Then we also have option of IFCs, industry foundation classes. The software can export in IFC, then IFC can go. But currently, you understand that this thing is not easy, and anything to be accepted at mass level, it should be very easy to use. So that is why BIM is having a lot of problems. So you can say this is some maturity level. If I'll say of BIM, it can be some like -1, a premature BIM, which has a lot of information in it. Even now, if it is like construction is going at site, I can put information in here. The color will change as it is. We are going in one more lift above, one more lift above. So I can see my construction data here also.
Okay.
So thank you, Mr. Kumar, for sharing your valuable experience. I'm sure all tuned in now will agree that geographic information systems plays a crucial role in civil engineering. So if any further questions are there, people can ask. We can move ahead with the further questions if anyone is having any question.
I have one question. For sure, a lot of people must have been intrigued by this technology and would want to learn further about it. So, could you just give us a brief about the baby steps? The initial steps are definitely the difficult ones. So, how could one start learning about it? My second question is, what is the industry demand for this technology, and what companies, if you could name some, are looking for candidates that are well versed with this technology?
Okay, so you have just asked two questions. So first one, how to start. So like how many of you in this group are BTech and how many of you are MTech? It's like 50-50 weightage or what?
No, so sir, 40% are from BTech and 60% from MTech.
Okay, 60% people are from MTech.
Yes.
So for the BTech people, you can obviously go for your BTech project. Take under some professor, good professor, geomatics department or whatever. Take up a project, and based upon your interest, like if you would have studied structure, steel, even water supply system, whatever it is, that take a example project and just try to model it on GIS easily. And how to model it on GIS, so that exactly that what I'm saying, you learn step by step. So suppose if someone is having a very basic PMGS for a road, someone has taken a project of that, so just download dem file of that location from United States Geological Survey, set the coordinate system in QGIS, import that data there, and as I said, a vector layer. So add a vector layer, draw your road by hand on GIS only. After that, you can go to Civil 3D and just refine that alignment, design it, then make it into a 3D. So that's how you can do it. For the MTech people who are in they are very much specific to a domain. So structure people, as I'm saying, you can see the GAD of different type of bridges. You select any bridge, you select Chenab bridge, you select that 141 meter pier which is being constructed by Railway Northeast. Select that bridge, take its elevation model from again United States Geological Survey. Go to QGIS plugin library, just search, type keywords yourself, like type a profile plugin. You will get at least 15 different type of profile plugins. I have not even tried all of them. Majorly I have tried. So just take a profile tool, create a profile of that bridge, see what more data you can get from that. So those are for the structure guys. And for the tunnel guy, obviously, you have to work in very much coordination with Bhuvan. Take the geological data, because tunnel goes, obviously bridges goes, but tunnel without geological and geotechnical data, it cannot even start. The terrain is very important. So just take that layer. I showed you that URL you have to copy in WMS Web Service layer. Put it there and then connect it, and then just see where a lot of tunnels. Now, in I think Udampur Ramban, there was some package of some contractor near that Khuni Lala. There is some collapse has also happened. So just take that case study, put it in GIS, see that how terrain, how contours are going there. Just try to figure out yourself what could be the possible reason of the failure. Read the research papers which would have been there now. There are a lot of case studies about that tunnel collapse there. A lot of other collapses also are there. So you can do learn. You see some of the great performing tunnels like Chennai National Tunnel, you can take for the example. See how that layout of the portals have been done. Other tunnels which are being constructed, see that. So that's how you can incorporate GIS slowly and slowly. For that rock class classification, if you have some data in your, like someone would have done some MTech or PhD thesis on some of the tunnels, so you can just take that data and just draw it on a plan, QGIS map, and see how the class of rock is varying, and then connect it with the geological fault and try to establish some correlation. So that's how we can do. And second question, the industry demand. So currently it is zero, to be very frank, because no one knows how to use this. So you have to create this demand. So like I'll tell you, in my company, name the most senior, most technical person who reviews everything. So when for the first time I show him, so I was thinking it's some toy. So saying that the coordinates same, if I measure the distance will be on scale or on all. So it took me at least, you can say, 1.5 years in my own company to make them understand that this is the thing, we have to go with this. Every decision which they were asking, I always used to open this in every meeting. See, if a meeting has to go, this has to be there. We have to show on this. And then this thing I can very proudly say, like the whole tunnel and survey manager at our site, he has constructed some 2-3 tunnels in Himachal. It's 18 years of experience, very more experience than me. So he's from a very normal private college and he has done very great work. He's a very talented guy. And so in our Shimla project, he's the head at the site for that whole survey and tunnel works. So after a span of 7 and 8 months, he came to me and told me, please teach me this software. This is the future. That gone are the civil 3D and global mapper days. What we can visualize is we cannot visualize it anywhere. So in my Shimla project, every survey is not learning QGIS. I made some 10-day webinar series. So like everyone in my company now have started understanding the applicability of GIS in the sector. You see, because GIS, all this thing now, earlier we, as in the highway fraternity, have not explored that much into the hills. The first four-laning project was itself in Jammu, Udhampur, Ramban. That was the first four-laning venture. After that four-laning, Himalaya started. Then we started facing these problems of slope stability. We have to go tunnels. So that knowledge transfer is coming from hydropower to highways now. So that is why. But hydropower, it has a very huge acceptability. Wherever you go in a hydropower company, you take any company like one of my junior, he has shifted to Adani Power. So he's working there. He is completely working on GIS. He was me in that consultancy. We used to work together. And another junior, he went to say some HCA, Hindustan Consultant Associates in Delhi. They are also working on GIS. So hydropower, it has a very huge acceptability. Roads, still people have not seen its value potential because just now we have entered into the hills. But slowly it is coming. Drones are being accepted. So yeah, I think it will take time, but yeah, there will be acceptabilities. And as you regards to the company who are asking, so I would always say, like, if whatever company till now I've applied, I think I made 2 times I've chose the company. So never formed a very good resume for me because I believe in this. If I have done something, if I've worked on something very diligently, it will show in my skills the way I give the answers. I don't need to have certificates and write it in my CV. So I tell them very confidently that I work on GIS. Whenever I'll come on a project, that will be my working interface. I'll work on that. So acceptability currently you have to bring. So, but yeah, as BIM is being coming very much into the sector, it is being. I can tell you one more example. Like for this, the tunnel additional, I had to go to NHI headquarters to discuss. So the member and CGM were sitting there. So when I showed them, there was so much like I would say uh, motivated to see this to be implemented. So they have asked me to give a webinar to NHI, to all the DPR consultants in the country, how they can use GIS and make a DTM model. So that every Sunday NHI conducts a webinar for all its employees. So that webinar they have also asked. So whenever I go there, now that DPR consultant and other consultant, detailed design consultants who are coming there, they have stopped seeing in Google Earth that NHI headquarters. Wherever I go, they ask for this QGIS. From other people, they have also started asking. So yes, acceptability you will have to create, you will have to show.
So for the image that is on screen right now,
Yes.
you most likely had to use QSWOT for the soil and assessment thing for, let's say, the hydrological properties of the river that is flowing right below the bridge. And let's say you used Midas or Plexus to create the bridge. And what other plugins did you have to use for this project?
See, as I say about plugin, so that superstructure analysis for this particular bridge was done on Sophistic. So we used Sophistic for that, and then Geo5 we used for slope stability analysis. In Geo5 we did all the parameters, and then Rock Lab we used for this because you see, we have to see from a practical point of view. The geotechnical consultants in our country currently, they don't use triple core barrel. That is a very major problem. If you have a triple core barrel, the core will be very fine. You can see the discontinuities in the start and everything. The single core barrel, now what it does, it deforms everything what you are getting. So then we also use Rock Lab because there you have to go, you have to give this dip angle and everything. You have to then it gives the C5 value. So it was a combination of softwares we used.
How big was your team for this particular project?
Hello?
So I was asking how big was your team for this particular project?
So I'm working with 7 consultants, out of which 7, 2 are MNCs, namely Sistra and GeoConsult. So GeoConsult is designing tunnels. They have a team of I think 20 people. Sistra has 2 offices involved, Kolkata and Hyderabad office. It's also an MNC. 5 are Indian consultants. They are working also there for MEP works. Structural design, we have 2 different consultants. Then we have a slope stability consultant. So,
and do you ever offload this analysis part to, let's say, institutes like IITs, or is it done purely by your team?
See, actually, I have not put it in my LinkedIn, but I'm currently doing my executive master course from IIT Kanpur. So right. I went there for 20 days. My guide is Sudip Kumar Mishra, sir. There in structural and vibration analysis. So my MTech thesis topic is also dynamic analysis of tall piers. Shimla's 120 meter I have taken. I had a fight with the consultant. You have to do analysis in that way. What is that? So that I'm learning myself. So there, I've seen in IITC, So one of the PhD guys, I saw him. I was very much motivated. My professor was saying me, why don't you come from PhD in Kanpur? Can be a professor. You have industry experience. So actually, one guy I saw, he was so talented. I can tell you, means the knowledge he had was just amazing. He was from environment department. I interacted with all the departments in IIT Kanpur. So then I went sitting with the HOD of Kanpur. Then I told him that sir, that guy was very talented. Why can't we have in our academic institutions that gap filled of industry experience? Why can't we have it there and all? So he told ki PhD is a different game, like that research altogether. Even those MTech serious students who are doing MTech seriously and thinking about research in future, you have to define a problem statement. So that problem statement you yourself has created, and that frustration which will come when you will not get the result that has been created by you, then you will have to motivate yourself again, that you stand up again and find the solution, and then at the end of your PhD you defend it, you get the thesis and done. So that is the scenario for our industry and academics. So there is a huge gap. So these type of bridges, if I'm seeing the consultants which I'm working with, so that exposure, there are IITs like IIT Bombay. There is Dipankar Chaudhary sir. For one course I went to him also. There is Vaising sir in IIT Roorkee. There are some professors who have a very good know-how of industry, but still I see that majority of the industry, they are lacking that experience. So for these bridges we have went with, but we have only went with consultant, those third-party consultant, for the analysis, for the proof checking. And if I tell you one example, NPCL, he was the HOD of IIT Bombay. Now he is, I think someone else is there. He has, someone else is there. So he was designing the foundation for NPCL, Nuclear Power of Corporation of India. So first time a nuclear reactor in this country is being built in Hisar. So why first time in Hisar? That's special because that has a sort of a alluvial strata for a nuclear reactor to be located there. So what they are doing raft and pile foundation. Now whatever our pile foundation design till date we are doing in our country, we never take any contribution from the raft of the pile, that pile cap, that it will resist some bearing capacity. But what they are doing there, 40% of the load is resisted by raft foundation and 60% load is taken by pile foundation. So they have optimized, I don't know, like 20 to 25% of the cost of that nuclear reactor, and that is being done there. So design was done by IIT Bombay, sponsored by NPCL and BARC, Baba Atomic Research Center. They proof checked that it is a design. So there are, like, it is growing, industries and academics, that gap is growing, but still that gap needs to be filled.
Right.
Okay, I believe everyone has something to learn from it and will have surely been inspired from your presentation, and thereby they'll definitely work upon GIS in the future and create a demand. So if anyone is not having further questions, we could end our session over here. Thank you, Mr. Kumar, once again for this wonderful session and presentation. So,
Yeah, thanks a lot. So it was really very great interacting with you all. So I can tell you my experience when I went to Kanpur. So that HOD, he himself told me that there was a course he taught there. So first day he asked the whole branch, how many of you want to go into the core sector? No one raised their hands. So he told me, I gave my best. So Priyank Ghosh sir is the professor's name. He's the HOD of Kanpur. He said, I gave my best. I gave my best what I could do. The best sort of presentations I made. Whole semester I taught the students, and at the end of the day, the last lecture I went in the class, and I asked those students, like, how many of you will now be joining core? He said there was no hands raised still. So he was very much demotivated. So, but when I'm seeing the motivation of you guys, it's really great to see. Like, I can see like Lakshya Sen's match was going on, but you all are sitting here and just for this presentation for the subject, and it's really good to see, and it's very heartening that in colleges people are still very much interested about core and they're taking this subject seriously. So yeah, that's it.
yes, so we are honored to have you here, and we definitely learn something or the other from this. And I believe that future some or the other person will definitely work upon even in their PhD thesis
Yes, yes.
or in future job perspective. So thank you once again.
Yes, yes. Thanks a lot.
Uh,
And you can message me on LinkedIn if you are using GIS by yourself. No, you stumble
okay.
upon some problem. So any one of you can message me on LinkedIn.
Yes,
Just
sir,
in this
sure. We'll
reference,
be definitely reaching out to you with any
can help you
problem
out.
if we are facing.
At least I can help you frame the problem statement perfectly. Yes.
Yes, sir, sure.
Okay. Thank you.
So we can end our session over here. Thank you. Thank you all for having this wonderful session and making it really pleasantful. Thank you. Thank you once again.
Thanks a lot.
Thank you so much, sir.
Thank you,
Okay.
sir.
Thank you.
Thank you.